Hello everyone, welcome back to my YouTube channel. So on day 25 of AWS series, today we are going to discuss about AWS Network Load Balancers. So in previous video we have already discussed in general what is load balancer and what is the purpose of load balancers. So in this video we are going to focus on network load balancer. So what is a network load balancer in AWS? In short form, we call as NLB. So a network load balancer is a type of load balancer provided by AWS that operate at a layer 4 of OSI model. So the full form of OSI model is Open System Interconnection Model. So in OSI model, basically we have a 7 layers and each layers will have their own job. So in general, just understand the OSI model. Basically, the purpose of OSI model is to how basically computers and network will communicate with each others. We will discuss in the OSI model in any of the other video in another videos in a detailed manner. Just understand the network load balancer work at transport layer of the OSI model. So basically, a network load balancer serves the single point of contact for a client request. So whatever the request, the end user will send a request to access any application. The request will receive by the network load balancer. In our case, if we are using a network load balancer, maybe if you are using another load balancer like application load balancer or gateway load balancer, then the first point of contact for that particular request will be the specific load balancer which you are using. So client send a request to a network load balancer and the network load balancer send them to a target such as EC2 instance in one or more availability zone. So why I have mentioned here availability zone, because as we know the availability zone are nothing, it's just as data centers, like each single data center or the physical data center we call as a availability zone where we have servers, routers and firewalls, lot of things. And we know AWS has multiple data centers across the globe. So when we configure a network load balancer, we have to enable a one or more availability zone. So in general, network load balancer, again, it's a load balancer and the purpose of load balancer is to distribute the traffic. So same way or same concept here we have with network load balancer as well, like it distribute or it basically handle millions of requests per second with low latency. So as we know, if latency will be low, then the response time will be high. Now let's understand the key components of network load balancers. These components we have to configure, or like it will be created during the creation of network load balancer. So the very first is listener. So basically a listener is a process that checks for the connection request from client using the protocol or port which we configured. So before you start using your network load balancer, you must add at least one listener. So the purpose of listener is to listen the request from the client. And based on the listener rule which we create, the request will forward to a specific target, like where it needs to reach. So if your load balancer has no listener, it can't receive a traffic from clients, and the rule that you define for a listener determines how the load balancer routes request to a target that you registered, such as EC2 instance, and it supports a protocol TCP, UDP, TLS and TCP underscore UDP. So these are the protocols supported by a listener which we configured as part of network load balancer. Another component here we have a target group. So basically target group basically is a collection of instances. For in our case, if we are talking about EC2, then multiple EC2 instance will be attached to a single target group. So basically target groups use a health check, and based on the health check it determine, okay, where I need to send a particular client request. So it always send a request to a healthier target. So these are the two main components of network load balancer. Now let's understand how basically a network load balancer work in background. So basically network load balancer use a flow hash algorithm. Each load balancer will use its own or any one of the load balancer, or I would say a routing mechanism to route the traffic. So in network load balancer, it use a flow hash algorithm. This we don't need to configure this algorithm. This is a part, or this is like basically on this particular algorithm is used to create a network load balancer. So for each new connection, network load balancer use a hash based routing mechanism. It calculates a hash value based on the following parameters. So if you are using TCP or UDP protocol, so it basically calculate a hash value based on the source IP address, source port, destination IP address, destination port, and the protocol. So this calculate a hash determine which target in the target group will handle the request. So in simple words, we can understand whatever the client send a request to a particular target of, for example, a EC2 instance where we have hosted our application. The first point of contact for that particular request will be a network load balancer, and then it will go to the listener, because if we don't have any listener on network load balancer, then it will not listen any request from the client. Then it will, from listener, it will pass through to the target group, and in target group we have a health check. So based on the health check result, it will pass the request to a healthier target or healthier EC2 instance. Suppose we have two EC2 instance, and one of the EC2 instance is getting lot of load or lot of traffic. Maybe when the health check will be performed for a request which we will get from the client, maybe that EC2 instance will not, the result of that particular EC2 instance may be unhealthy. So that request, the new request which comes, that will not go to that particular target. It will redirect to the another target, which result will be a healthy. So these are the health check patterns basically we have to specify when we configure a target group. So that we will see in a demonstration when we do. Just summarize, let me summarize it. So how basically this network load balancer is going to work for me. Like, I am a client, I need to access any application. So if I'm sitting on my room, I'm not sure if I'm browsing facebook.com. I don't know where these facebook.com application or website is hosted. For me, I'll just simply search on my laptop, okay, www.facebook.com. Now, this is the request which we have initiated from our local system. So the first thing, it will go with her DNS name of Facebook. So it will identify, okay, and from where I need to go. So for that particular request, first point of contact will be network load balancer. Once once the request will reach to a network load balancer, then it will go to the listener, because the listener is the one who receive or who listen the request which is initiated by a end user, and the listener will basically pass that request to a target group, and under target group the health check will be performed on each target which is part of target group, and based on the healthier target the request will be received, and from that server basically will send a response back. So that's how basically a traffic flow if we are using any kind of network load balancer. And again, there are multiple type of load balancer available in AWS. Like another, we have application load balancer, then we have a gateway load balancer. So each load balancer type serve a different purpose or work on a different OSI model layer. so their configuration also will be like little changed, but the concept, overall concept of load balancer remains same. Now another thing we have in NLB is availability zone and load balancer node. So when we create a network load balancer, we have to enable one or more availability zone. Availability zone are physical data centers which we have across the globe. So for each enabled availability zone, AWS automatically create a load balancer node. These NLB nodes are responsible for receiving and routing traffic in that specific availability zone. So for this, basically what will be the traffic entry point? So when a client make a request, DNS of the NLB return one or more IP addresses and each corresponding to a load balancer node in a specific availability zone. And client typically connects to the nearest availability zone. Then we have a target routing. So by default, each node routes traffic only to the registered target in its own availability zone. So let's understand this availability zone concept in with the help of one diagram. So let me go to my next slide. Okay, I'll come to this slide little later. So okay, so this is the user which is sending a request to this EC2 instance where we have hosted our application, and this user is not aware, okay, on which availability zone I need to send a request. So this is, for example, this is a load balancer which we created in US-East-1A availability zone. So this is our availability zone. So the request, this request which is initiated by this user, this request will go to this EC2 instance which is part of US-East-1A availability zone. If we have another EC2 instance which is not part of this particular availability zone, then the request will not go to that particular EC2 instance. The request will be received by only this EC2 instance which is part of this availability zone. So this is the purpose of availability zone. So each availability zone will have one load balancer node, and that load balancer node basically distribute the traffic to the EC2 instance which is registered as part of that particular availability zone. Now we have another concept which is cross zone load balancing. So this scenario we have discussed when we don't have any cross zone in our network load balancers. If we have enabled a cross zone load balancer, then it doesn't matter if the request will be received by, basically the request will be received by any EC2 instance. It doesn't necessary it should be a part of availability zone or not. For example, here the request is coming from this availability zone, but under the node, basically the load balancer node basically distribute this traffic to any of the EC2 instance, even it doesn't part of the availability zone. So this is the purpose of cross zone load balancing if we have enabled. So now let me go back to my previous slide. So the cross zone load balancing allow each load balancer node to distribute traffic across all registered targets in all enabled availability zone, not just is its own. So this is the purpose of cross zone. When cross zone load balancing is enabled, each network load balancer node can send traffic to any healthy target in any availability zone, even if the traffic come into a different availability zone. So this is what we have discussed here. So suppose the request is coming to this availability zone which is US-East-1A, but this EC2 instance, one EC2 instance we have part of this availability zone, and another EC2 instance we don't have a part of this availability zone. But the load balancer node doesn't, like, it basically send or forward this request to any one of the load balancer or any one of the EC2 instance which is not part of that availability zone as well. So this is the whole purpose of cross zone load balancing. And there are benefits as well if we are using a cross-show load balancing. So it is basically help us to better utilization of our resources. So like it is not like, okay, if the request is coming from one availability zone, then the request will always forward to the EC2 instance which is part of that availability zone. So in that case, if we have another EC2 instance in another availability zone, then basically we are not utilizing that resources. So if we are using a cross-chain load balancing, in that case the resource utilization of all resources we are doing higher availability and fault tolerance. So in case if we are facing any issues with that EC2 instance for availability zone, first availability zone, then in that case the application will face a downtime. So if we are using a cross-chain load balancing, in that case, if suppose in case something goes wrong with that EC2 instance which is in availability zone 1, maybe the traffic then distribute to another EC2 instance which doesn't part of that availability zone. So this is the whole concept of cross-chain load balancing. So this we already discussed. So this is what we are going to implement. We are going to create a network load balancer. We are going to create a target group, and we will create two EC2 instance which we will associate with this target group. And on these target group we will set up nginx web applications. Then we will try to access our web application from the DNS name of network load balancer. So we will get to know, okay, the configuration which we have done of the network load balancing configuration is working fine as soon as we receive a response from one of the EC2 instance. So let's move to a demo and then we will set up this particular scenario. So this is the steps which we are going to set up. So I'll come to this slide little later. Let me go to my AWS console first. Okay, so I'm using my root account here. Okay, let me check the MFA code. Okay, so the first thing what we will do, we will create a two EC2 instances. So let me go to EC2, and before that let me do one thing. Okay, it's fine. Let me launch a two EC2 instance. We will use a default VPC. Otherwise what we can do, we can create a custom virtual private cloud, and on that particular VPC we will launch our EC2 instance, but it's fine, we will use a default VPC only. So let me give her here name bev-1, and let me select my AMI which is U12, and let me create a new key pair, bev key. Okay, now let me edit the network settings. So what I will do here, in subnet I will choose a subnet which is AP South 1A, and let me create a, or let me choose a existing security group. So here we will use, okay, we have two launch wizard 1 and 2, so let's use launch wizard 1, and rest all these things I will leave default. Let's see in advance if we have to change anything. Okay, now let me launch the EC2 instance. Now let me launch another EC2 instance. So let me launch here now web-2, and again I will select my AMI Ubuntu. Okay, in key pair I will select my key which we have created, web key. And another in network settings, let me select a subnet again which is AP South 1A, and I will again choose the existing security group which is launch wizard 1, and let me launch the EC2 instance. So we have created a 2 EC2 instance. Let me refresh it. So let me connect to both of the EC2 instance, because we need to install the nginx web server here. So now let me open my command prompt, because in download location I have my private key file. Now let me copy this command. Okay, so I am connecting to my first EC2 instance. Now let me connect to the another one which is web 2. Oh sorry, let me go back. Let me copy the command and let me open another command prompt. Okay, so we are connected to both our EC2 instances. Okay, so now what I will do next, let me update the package first. Sudo apt update. Same I'll do on this instance as well. Okay, so for this is completed. Now let me install a nginx application or web server, sorry. Sudo apt install nginx, and same command I will run on this EC2 instance. Okay, so now let me try to access the nginx web server from both the EC2 instance. So let me copy the public IP address. So for this we have a public IP address 131, and for another we have 195. Okay, so one thing we have to do, as we know, nginx web server work on port 80. So for that we have to enable a port as well. So for that let me choose like a security group launch wizard 1. So there we need to enable a port 80 because we have not added any rule here. So let me go to my launch wizard 1, edit inbound rule, and here I will another rule. Let me select HTTP and source I will choose anywhere. Let me save the rule. Now if I'll refresh this screen, okay, I'm getting a response. Now let me search again. So we are getting a response on both 195 and 131. It means the EC2 instance has been nginx is installed successfully in both of the EC2 instances. Okay, let me do one thing, because in both the IP addresses we are getting a same response, so we will not be sure okay from which servers we are getting a response when we browse our application from network load balancer DNS name. So what I will do, I will edit the default HTML page for these two applications and we will make some changes, so we can easily identify okay when we access our application from network load balancer, then from which servers we are getting a traffic. So for that, let me do one thing. Let me go to my command prompt here. So let me clear the screen. So the first thing what we will do, we will go to the cd uh, let me go to here, cd slash bar slash, sorry, not bar, www slash html. So here if I'll go do ls, so here we have a page called index.nginx-debian.html. so we will edit this page. So before that we need to give a permission to this html page so we can edit it. So let me do that. Sudo chmod, I'm giving a full permission. Okay, so now let me again clear the screen. Let me do a nano editor and here I will search. So here what I'm going to do on this, basically I'm going to put -bev1 and let me save it. So if I'll refresh this, okay, let's try to refresh this one. Okay, so it means it is not changed yet. Let me go back. Let me edit it again. Okay, so we have added bev and welcome to nginx bev1. Okay, maybe we need to do a reboot as well. Okay, so we'll do let me do one thing. Till then we will, okay, welcome to nginx bev1. Here from here basically we are getting a title, so it is not correct. Let me change it back. So instead of title, let me remove from here bev1. So in heading basically we have to add nginx web-1, and now let me save it. So if I'll refresh it, okay, now we are getting welcome to nginx web1, and same we have to do a changes on this as well. So now let me go to cd slash bar slash www slash html, and here again I will use nano editor. So let me change the heading from here as well. So here I will put bev-2. Now let me save it. So let me refresh this page as well. So okay, so it will easy to identify when we will access this application from network load balancer DNS name. So this is completed. Now let me go back to my slide. So here what next we have to do, we have set up a 2 EC2 instance, we have created a 2 web app. So now let me create a target group first. So here you can see in load balancer we have a target group. So let me create a target group first. Create target group, and we need choose a target type. So here we will go with instances because we have EC2 instance. So let me give a name, my target group, and protocol we will use HTTP because we are running our nginx web application on port 80. If we have another ones, you can choose this protocol from here, and similarly the port range you can specify. And in BPC we have only one virtual private cloud, so that is fine. Health check pattern, so I'll use HTTP. If you have HTTPS, you can select from your HTTPS. And in advanced, let's see if we have to do anything. Okay, I will leave everything default. So let me create on next. So we have created a target group. Okay, we have to register as well, so let me do that. Okay, so you can see 0 healthy, 0 unhealthy, so it will take some time. Let me go back to my target group. We are getting not associated. Okay, from load balancer it is not associated. So now what we will do next, we will create our network load balancer. So for that I will go to a load balancer and let me click on create load balancer. So here you can see we have three types of load balancer: application load balancer, network load balancer, and gateway load balancer. So for this particular demonstration we are going to use a network load balancer. So let me hit on create network load balancer, and here let me give a name, my NLB. And here we have an option, we need a internet facing or internal. So we are going with internet facing one. In networking settings we have to select our VPC. So this we have only one VPC, so it is like default it is automatically taken. If we have multiple VPC you can select from here. And availability zone and subnets. So let me choose my first availability zone, AP South -1A, and the subnet. If you have multiple availability zones, if you want, you can enable that one, that option as well. If you have like multiple EC2 instance in multiple subnets, so you can select. Security group, let me choose my launch wizard one. And listener and routing. So protocols we have to use TCP and port 80, because this is what we are going to like on this particular port we are going to listen our application. And in default action groups we have to select our target group here. Okay, so we are not able to see our target group. Let's see if target group is already created or not. Let me open another terminal to our console here. So let me go to my target groups. Okay, so okay, so we have to register a target here as well. So let me go and select my both EC2 instances and include a pending below and register it. Okay, now let me go back here. Let me refresh it. Sorry, not this one, this one. Okay, why it is not visible here? Okay, let me go back. So we have two targets here, that is fine. Okay, let's wait couple of minutes. Sometime it takes time to reflect the changes as well. Let me select my all security group as well in case if. Okay, so let me cancel it. Okay, UDP. So the issue we are facing, we are not able to add our target group in our load balancer. Here we can see health target group is not configured to receive a traffic. Okay, Let me go to here, associate with load balancer. Sorry, let me close this. Let me create another load balancer. Maybe let me select network load balancer. Let me give a name, my NLB, and we need a internet fetching. That is fine. Networking is fine. Availability zone, I will use associate AP South 1A, because here we have our EC2 instances. Let me select this launch wizard one as well. Okay, so maybe something we have missed. Let me select my all subnet. Let's see if still we are able to see. Okay, no, so nothing to do with subnets, because we have our EC2 in AP South 1A, so we will select this one only. Let me give a moment. Okay, so there is one issue. We are using a network load balancer, so we have to use a TCP protocol. But in our case, if I'll go to my target group, here we have used a protocol HTTP. So this is wrong. So let me do one thing. Let me create this network target group. Let me create a new target group. So again, I will choose a name, my target group, and here basically we have to choose a protocol called TCP, because we are going to use a network load balancers, and rest all the fields I will keep it default. Health check, because we have to do HTTP only, because we are using HTTP sorry, a port 80 for our NGNS web servers. Let me click on next. Let me associate my EC2 instances, and let me create a register. Okay, so now let me go back to my load balancer. Let me create a load balancer. I will choose a network load balancer from here, and give me a name, my NLB, and internet fetching will go from here, and here I will choose availability zone, which is AP South 1A, and in security group let me select launch wizard 1 as well, and here we can see our target, which is my target group, which we have created. Because the networking, if we are using a network load balancer, you have to select a TCP protocol. You can see the listener type, we have TCP, TLS, UDP, and TCP underscore UDP. You cannot use HTTP one. Okay, so if you want to give a load balancer tag, I leave it default. Global AWS global accelerator. So this particular thing we will discuss in another videos. So basically it's a global load balancer which you have to create across multiple zones or multiple regions. So now I will keep everything default. Let me hit on create load balancer. So load balancer has been created successfully, and this is the DNS name of our load balancer from which we should able to access our application. So let me copy it and let me search for HTTP. Okay, so we are not able to access our application. Let's wait couple of minutes. Let me close this. So it will take us couple of minutes. Like we have just now we have set up a load balancer, so it will do health check, and it will go to, like, in background basically a lot of things will happen. So let's wait couple of minutes. So after waiting a couple of minutes, I can see I can access my application from the load balancer DNS name. So we are now, you can see the request is coming from nginx web-2 If I refresh it back again, or let me copy the IP and let me open another tab. Let's see if we are getting a response from web1 as well or not. Okay, so still we are getting a web2. Okay, if multiple user will access this application, then definitely it will go to the another web server. So let me copy it and another open another browser. I just want to show you if we are getting a response from both of the server or not. So I have to open my Mozilla. So you can see on Mozilla browser, I am getting a response from EC2 one as well, web one basically. So that's how basically we can configure a network load balancer for our application. So I hope it's clear. In case if you have any doubts, you can ping me over comment box. So that's all for today. See you in next video. Thank you so much.